Hello everyone, welcome to this video. I want to talk about building a power supply for a tube microphone. More specifically, it is about this East German beauty, which is a CMV 563, and we are going to look at how you can make a power supply for yourself if you own one of these beauties. If this sounds interesting to you, stay tuned. So here on my table you can see all the components that are needed. Of course you need the microphone. These microphones, they have a special connector, which is a 5-pin Tuchel connector, which is called a Tuchel in German. And there's also a variant of this microphone that has a switchable polar pattern that is called the UM57 microphone. It looks a bit different, the capsule head looks a bit different, and that uses a middle pin, so this has a 6-pin connectors. So here you can see the plug that fits to the socket, and as you can see, this one is equipped with the 6th pin, which is not used with this particular microphone. I have a bunch of these connectors in stock, and so I can always make custom cables if I need to. On the other side, I decided not to go with the original design, but I used a 5-pin XLR connector, like you can buy in any electronics part store. And also you need a special cable. Here we have decided to use the summer cable, and it's a special type that has multiple wires inside. It's called SC octave tube. This is a very good quality cable, and it does not only have the 2 XLR wires like any XLR cable, but also it has additional wires for the filament and the plate voltage that go to your tube microphone. Of course, you also need the sockets on your power supply, so you need the 5-pin XLR socket and then your standard XLR output socket, and this is where you can take your standard XLR cable and feed the signal to your microphone or recording amplifier, whatever you like to use. Then you can connect everything and your microphone will work. The plug is still very new, so it's a little bit tight, but it works. Okay, let's have a closer look at the PSU. Yeah, here you can see a close-up of the power supply. I used 2 transformers. Now I like to use salvaged parts, and I always take these transformers out of wall plug units which are not needed any longer, and I store them. You have to write down the values so you can select the matching transformers. If you're building a tube circuit, you need a little bit a different transformer than for a standard op-amp or transistor circuit. Now with op-amps and transistors, usually you need low voltages like 9 volt, 12 volt, 15 volts. Sometimes 2 windings are required. If you want to build op-amp circuits, you need a positive and a negative rail. But for tube circuits, you usually need a winding for the heater and also a winding for the filament. Now, if you don't have a transformer that has these separate windings, you can also use a back-to-back design, which is what I have used here. So this is the main transformer. It puts out 9 volt AC, and then I take the 9 volt AC signal and feed it to the low voltage side of a second transformer, and at the high voltage side I get a high voltage again. So you can pretty much use, like for instance, a 12 volt AC transformer works very well together with a 9 volt transformer. So I always like to have the second transformer have a higher voltage than the first one. So when I transform this back to high voltage, I will get a little lower voltage than 250 or 230 volts, maybe like 200 or 190, something like this. And then here on this perf board, you have the two separate regulator circuits. Now the original design for these PSUs that were used for these microphones, they only have a regulation for the high voltage. We are going to look at the schematic in a bit. And I decided to build a regulation for the low voltage, the filament voltage, as well as for the high voltage. Here you have the high voltage section and this is the low voltage section, right? So you have a bridge rectifier in both sections, then you have filter capacitors in both sections, and then you have voltage regulators. For the filament, I use an LM317, and for the high voltage, I use a special device which is called an LM8. That is a special high voltage regulator that can be used up to 450 volts. Now I like to keep the dropout voltage not too high, because if you understand a little bit how these regulators work, they are basically shunt regulators. That means they have to burn the excess voltage, and that creates a lot of heat. Now with the filament, since the tube draws about 100 milliamp of filament current, I have to use a heatsink. For the high voltage, we don't have to use a heatsink because this is only 0.9 milliamp of current. So we're talking 900 microamps of current only. You have to use a protection diode for the high voltage regulator. The LM317 has already one built in. Now, as you can probably see, these devices are pretty much used in standard configuration, and I sometimes have to use resistors in series in order to get the exact values that I need. That's because I want to use parts that I have either salvaged or I already have in my parts collection. But if you order new parts from Mauser or DigiKey, you will pretty much be able to find almost any resistor that you need. But if you only have like E6 or E12 series of resistors, you will probably also have to put some resistors in series in order to get the exact values. The formulas for the voltages you will find in the datasheet for these devices. And yeah, pretty much the standard circuit as well here for the low voltage regulator, the LM317. And that's pretty much all that is needed. Now here you have a loop wire that goes from the XLR socket to the 5-pin XLR socket. This is where the audio signal passes through. And then you feed the high voltage and the low voltage to the 5-pin XLR socket. That is pretty much it. And I added one additional resistor here to drop the high voltage a little bit. As I said, I want to keep the dropout voltage in the voltage regulator as low as possible. So here in this particular case, maybe going from 150 down to 120, which is okay. And here maybe 9 volts going down to 5.8 volts. Now in this microphone, the CMV 563, which you have here, you can see the label. Let's see, yeah. Neumann Gefell is the place where they have built it. And yeah, they used an E-series tube, the EC92, which is a triode. And this tube is usually to be found in audio circuits, but it can also be found in radio circuits. For instance, in the FM front end tuner circuits, you will find the EC32. Now, this microphone comes from an East German background. It was built in the 1950s, 60s, up until the early 70s, I guess. And of course, you have to understand a little bit the part situation. So they were not able to get the highest quality parts from all over the world, and they had to use parts coming from East German production. So for that reason, they had to select a tube from their own production by the company of RFT, which is basically only a label, and formerly privately owned factories were all grouped together under this label. So the tube itself had to be selected for very low noise. So if you take 100 tubes of a certain type and then test them in an audio circuit, you will find a bunch of them that will have lower noise than other tubes of the same make. And this is very important. You cannot use any run-of-the-mill EC92 tube inside of this microphone. It will simply not work. You have to use a special tube. And for that reason, they also used 5.8 volt filament voltage and not 6.3. So if the tube has a little less heat, there's less emission, and also this brings down the noise a little bit. For that reason, you have to use the voltages 5.8 for the filament and 120 volt for the plate voltage and also for the capsule voltage. Let's have a look at the schematic of the tube microphone. So here you can see a Czech web page which I found, where they show the original power supply, which is called N61. It's written here. And here is the voltages. So you can see 120 volts. That's the anode voltage. It says the plate voltage 0.9 milliamps, and the heater is 5.8 volt, and it even says 142 milliamps. I think I read 100 milliamps about the EC92, but I'm not quite sure. Maybe this is correct. Anyway, here's the circuit. As I said, it has a single transformer with two separate windings. This is for the plate voltage, the high voltage side, and this is for the filament voltage, for the heater. Pretty much the same like I used in my PSU, except that I used two transformers back to back because I did not have a single transformer with two windings. Now here they use this special light to show that the device is operating. I used an LED, which is more appropriate for these days. And here you can see that they had to take a lot of effort in order to get the voltages stabilized. So there's a lot of filtering going on with these resistors and capacitors. And then there's this very special voltage regulator tube. It is also a tube that they used for voltage regulation. But in those days, we're talking about late 50s, early 60s, these devices were only able to regulate very low current. So they were not able to use this for the filament as well. So you can also see a lot of effort here in the filament section. And so basically what they did here is build an LC filter. And then to regulate the voltage correctly, you would have a wire wound resistor, a potentiometer here, and you would have to adjust this to 5.8 volt. You can see the measuring point here, and here it says 5.8. Now, as you can imagine, if the voltage of your power grid goes up and down a little bit, you will never really get a very stable voltage for the filament with this circuit. So these tubes can handle a lot of over and under voltage, but of course it is better if you have a regulated voltage for the filament as well, and it will be 5.8 always, no matter what voltage is here. Also keep in mind, if you have one of these older PSUs, in Europe we used to have 220 volts AC coming from the power grid, and only a couple of years ago this was changed to 230. So if you're using an older PSU of this type N61 or the previous version was the N57, you always have to readjust this potentiometer in order to get 5.8 volt. Now this is the picture of the CMV 563. Here you can see the version that I have shown you. That is the M55K capsule. And there's also an M7 capsule, some call it a lollipop capsule. There's also a smaller version, this is the bayonet version, and then there's also a smaller version that screws directly onto the microphone body. So here you can see the circuit, and it also has the power consumption 0.9 milliamps. And here you can also see the pin out of the connector, and it's very important that you follow this very closely in order to get a functioning microphone. Here you can see how they make the voltage for the capsule. So the incoming 120 volt line voltage will go through this resistor network. It's a unloaded divider. It is unloaded because the capsule itself will not consume any current. It's more a static load, a static voltage that you place at one side of the capsule. Here this condenser isolates the static voltage from the tube, and of course the grid has to be at 0. Yeah, as you can see from the values that we are getting out of 120 volt high voltage, we are getting probably around 80 volt of capsule voltage, and then this gets filtered through this network here and then fed to the microphone capsule via this very high value resistor. Now these resistors are very difficult to measure. I don't have measuring equipment to measure 100 mega ohms of resistance. So, but I checked all the other resistors in the microphone to make sure they have their values. Some people like to upgrade these microphones with newer resistors, but I kept this one in original condition. Here you can see an original power supply. This is almost in original condition. I think this socket is not quite original. I think I've changed it because it used an older type of plug which I didn't have. So this is what it looked like. You could switch it on here, on or off. This is the pilot light, the fuse. And then there's these two Tuchel plugs that connect to the microphone side. This one connects to the microphone. It's written under here, you cannot see it from this angle. And this one goes to your mixing desk or preamplifier, whatever you want to call it. So with my PSU, I decided to use more modern plugs because I don't have an indefinite number of these connectors. And also, I think it makes a little bit of sense to use parts that are easily available. But you can, of course, use older parts as well. It works just the same. Now, a few words to the cable. When you make a custom cable like this, you need to understand that there is no real standard for these 5-pin connectors connecting to this Tuchel connector. So you can make your own judgment which pin of this XLR plug you want to connect to the cable and coming here to this plug, but you have to make sure that this plug has the right connections, and here on this side it is up to you. It's very important, if you do not build this power supply for yourself but for other people, that they understand that they cannot use any other cables except this custom cable which was made specifically for the power supply, because just because the XLR connector fits to the XLR socket, and you have a Tuchel connector on the other side, does not mean that the wiring scheme of the cable fits the wiring scheme of the PSU. So, as I said, there is no standard. I have found this 7-pin Neumann tube mic scheme, and I tried to follow this as closely as possible. So they use on the XLR side 1 and 2 for audio. Then they have on pin 3 the ground. On pin 4 they have the heater or filament. On pin 5 they have the plate voltage, 120 volt. And then on the 7-pin XLR for the Neumann mic, they use 0 to 120 volts, which is if you have switchable capsule head. On some of these microphones you can switch the capsule pattern between cardioid, figure 8 and omni. And 7th pin is not used. So we have no switchable pattern here, so we use only pins 1 to 5. And that's how I wired my XLR connectors. 1 and 2 is audio, G and D is ground, 4 is the heater or filament, and 5 is the anode, the plate voltage, 120 volt. And you have to make sure you have the right conversion chart. This is here how it converts to the Gefell, Neumann Gefell East German connector. And if someone uses a cable that is maybe made for another power supply, in the worst case you would have the 120 volt running to the ground, and then as soon as you touch the microphone you would touch 120 volt. So you need to make sure if someone else uses this setup, they understand you can always, for example, extend this cord on this side with an original Neumann cord, because this is Neumann standard, and then if you connect it with another Neumann cable it will work just fine. But on this side you cannot connect another 5-pin XLR cable as long as you have not made sure that the wiring is 1-to-1, so that each pin goes to exactly the same pin where it goes in. So this is very important, otherwise this setup can fail. Now if you buy a normal XLR 3-pin XLR cable, you can be sure that it is always made to the same standard, which is pin 1 is ground, pin 2 is positive audio signal, pin 3 is the negative audio signal. Another word to the cable used here, as I said, it's by Sommer cable, and the name of the cable is SC octave tube. And this cable has 5 wires with a diameter of 0.14 square millimeter and 2 wires with a diameter of 0.5 square millimeters. So what you can do is switch 2 of them in 2 pairs in parallel and use them for the signal, the audio signal. Use 1 of these, which are a little bit thicker in diameter, for the heater. As you have seen on the schematic, the heater draws a bit more current, like 140 milliamps, as they said here in the schematic. Then you can use the second thicker one as ground. Now, if you have 140 milliamps of current going through one of these thicker wires, then also you need a thicker ground wire. And the ground will also be the ground for the audio path. And the one that is left over here can be used for the plate voltage. Now, these cables also have a shield, and if you are familiar with standard XLR cables, usually they have two inner cables and a shield, and then you use the 2 inner cables, or the inner wires, I should say, for the audio signal and the shield for the ground connection. But with this cable here, it is possible to build an even better setup where you connect the ground wire only on one side with the shield. That means on the microphone side, the shield is not connected to the plug. The shield is only connected on this side to the plug. So that means you have a ground connection, but the signal ground and the shield will not be connected here. So that means when you have noise going into your cable, it will not be on the signal ground, it will only be on the shield. So it may not be a huge difference, but that's the way you can build it if you have so many cables inside of here. Now let's test the microphone. Here we can switch it on. As you can see, the LED is glowing red. And we will get a signal very soon. Like now these two microphones, they take a second to heat up. It's already working, as you can see. As I'm tapping the microphone, it works. Now maybe let's try it with a musical instrument. So guys, this is it. I hope you liked this video. If this is the case, please come back anytime. There will be more stuff like this. See you. Bye.